In this video, we'll take a few minutes to review how to do unit conversions, and I'll go through a more complex example with a compound unit of the sort that you sometimes encounter in physics. The basic idea of doing unit conversions is a simple one. One just needs to multiply by a unit factor, which is a ratio equal to 1, such that the units cancel. Let me show you what I mean with an example. So suppose we want to convert 30 centimeters to meters. What you need to know, right, is that is the conversion ratio, which is that there are 100 centimeters in 1 meter. So we can construct a unit factor out of this. So the ratio 100 cm to 1 meter, right? Because of the way these units are defined, that ratio is equal to 1. Those the numerator and the denominator represent the same thing. So to convert our units, so if we have 30 centimeters, we have to multiply by this unit factor in the right way, such that the units appropriately cancel. That's where things can get just a little bit tricky, because we have to watch what we want to cancel. Here we want to cancel the centimeters. When I wrote this ratio out, right, centimeters was in the numerator, so I actually have to turn this factor upside down. Let me do that in a different color. I actually want to turn this upside down and multiply 30 centimeters by, let me just rewrite this, by this ratio here inverted. So we have 1 meter over 100 centimeters. And what you can now see is that now my units of centimeters here and centimeters down here, those cancel. And so that leaves me with 30 divided by 100, or 0.3 meters. You can deal with any kind of conversion this way, so it doesn't have to be between different metric or SI units, as we'll see in the next example, but this is the general pattern of how it goes. Where things can get a little bit more tricky, however, is with compound units, and let me demonstrate what I mean by that. So let's look at the following example. So suppose that water has approximately a density of 1,000 kilograms per meters cubed in SI units, and suppose you want to know what the density of water in pounds per cubic foot is, so in English units, and I listed the conversion factors here, since those are those I had to look them up too, since most of the time in physics, and certainly in this class, we will be working in SI units. Okay, so in order to do this, right, let's write down what we've got here. So we have, right, we know that we have a unit of 1,000, our density is 1,000 kilograms per meter cubed. So we've got to deal with the kilograms and the meters separately. Let's do the kilograms first. So I need to set up my unit factor in order to cancel this factor of kilograms. Now, knowing the conversion factor, what we want is we want kilograms in the denominator here. So I'll put 1 kilogram there, and we have 2.2 pounds upstairs. Let me do a better closed parentheses. Now, where things get a little bit tricky is when we have to think about the meters, because when we've got a density here, we've got meters cubed down here. So we actually have not one, but three factors of meters we have to cancel. This is one of the more common pitfalls in doing compound unit conversions, which is why I want to highlight it. So, in fact, what we need to do is to have the right number of factors of our unit factor ratio in there. So let's get this set up first. So notice now I have meters in the denominator in what I was originally starting with. So in order to cancel out those meters down here, I need my meters in my conversion factor to be upstairs. So I will do that. I'll write 1 meter is equivalent to 3.2 about 8 feet there. But here's where I need to be really careful, right? Because I have 3 factors of meters down here. I actually need this factor 3 times. I'll write it out explicitly for sake of perhaps slightly belaboring the point here. And now I think you can see that now I've got 3 factors of meters in the numerator of my conversion factors to cancel the 3 factors of meters down here in the denominator of the original quantity, and I'll replace that with 3 factors of feet. Now, the more compact way I might write this is the following. So I might just write 1,000 kilograms per meter cubed. I've got my factor for going from kilograms to pounds. I might just, most of the time, just write 3.1 meter to 3.28 feet and cube the entire thing. You just have to remember to do that, and that is a potential pitfall. So now, however, having written these factors out, I can go and plug this into a calculator, and as long as I remember that I need 1 over 3.28 cubed down here, the result I get is about 62.3 pounds per cubic foot. Okay, so hopefully you can see how to convert units using this unit factor method. I really like it because it makes the conversions really explicit. You can always check to see that the units cancel appropriately. Oh, I should probably just mark that just for clarity. Notice that we have our 3 factors of meters canceling 3 factors of meters there, leaving us with leaving us in fact with pounds and then 3 factors of feet in the denominator. So indeed, pounds per cubic foot. Right. So this technique lets you definitively see what you're doing and helps to prevent the kinds of mistakes that can happen if you have a conversion factor inverted.